Hey there, welcome to Pomodoro Joe for Monday, October 23rd, 2023. Today we're doing LeetCode problem 342, power of 4. Yes, this is an easy problem. All right, given an integer n, return true if it is a power of 4, otherwise return false. An integer n is a power of 4 if there exists an integer x such that n is equal to 4 to the power x. Okay, so for example, n is 16. Well, that's 4 squared, so that's true. All right, n is 5. Well, there is no power of 4 that equals 5, so that's false. And then n is equal 1 is true because 4 to the 0 is 1. All right. And then we have some numbers that are actually, they can go, negative 2 to the 31 up to 2 to the 31 minus 1. Interesting. Do I have a solution to this? I do have a solution to this. Okay, so I don't think we can go into the negative territory because these are powers of 4 and 4 is positive. So anytime you multiply a positive by a positive, you'll end up with a positive. So I think we can ignore this part of it. We just need to focus on this part of it. All right, let's put 25 minutes on the Pomodoro timer and we will get started. Now, binary being powers of 2 and we're looking for powers of 4, there's probably something clever we can do with binary numbers, but I'm really not that clever. So let's just do this the simple, straightforward way. We're going to start with a value. We're going to set it to 1 because that is 4 to the 0. So we'll start at 1. And while our value is less than this integer n, we'll just multiply our current value by 4 to get the next power of 4. So it'll go 1, 4, 16, so on and so forth. Now, as soon as we are equal to or greater than n, we'll break out of our loop. And then we just need to check, is their value equal to n or is it greater than n? If it's greater than n, it's not a power of 4. If it's equal to n, that means we got a power of 4. So that's pretty straightforward. So we'll start here. We'll have some value. We'll set it equal to 1. Now, while our value is less than n, we'll just multiply our value by 4. So value will equal value times 4. All right. Now at some point, our value will be greater than or equal to n. Now if it's greater than n, we've overshot, and that means that we did not find a power of 4. But if it's equal to n, then we found our power of 4. So we'll just return val is equal to n. Cool. And that's it. Start the value at 1. Go through every blah, 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 and that's it. So we start our value at 1. While our value is less than n, we just keep multiplying by 4 to get new powers of 4. At the very end, we just check, was our value equal to n? And let's run this and see how we do. Okay, seems to work. Let's see if we can pass all the tests. And we pass. And let's see, we do okay. 52% for runtime and 30-something% for memory. So that's not too bad. Let's jump back here and see if we can speed this up just a little bit. We'll just get rid of some of these spaces. All right, and I'll actually compact this just a little bit. We can say times equals 4. All right, that's a shortcut in Python. Times equals 4. We'll just multiply our value by 4 and reassign it to value. All right, let's see how we do. All right, do a little bit better. So now we are at a 68% for runtime and a 39% for memory. So yeah, do just a little bit better. Now there's probably some things we could do. It's like clever things we could do, again, either with binary numbers, or maybe we could do some early outs, like just check if n is equal to 4, we return true. So we could do things like that, but I actually kind of like this. I think it's short, it's sweet, it works. Yeah, I'm pretty okay with this. Okay, we'll try one last thing. We'll just shorten up some of these things. We'll call this v. V is equal to 1, while v is less than n. V times equals 1. All right, this is probably as short as I can get it. I might be able to do this. I've never actually tried this. Let's see. We could try this. See if this works. All right, back down to 52%. So yeah, now we're back down to 52% with a 70% for memory. Now these are so close. Like, look at these values. So 38 milliseconds versus 40 milliseconds. This could just be whichever machine is running. It has some other process going on. It takes slightly longer. So we're all within a couple of milliseconds of each other. So I'm not too concerned with the performance on this. All right, well, that is it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.